Hello, welcome. In this part, we are going to discuss how to obtain solutions of first-order ordinary differential equations by the method of substitutions. Let's begin our discussion with homogeneous function. If a function f has the property that f of tx comma ty equals t to the alpha times f of x comma y for some real number alpha, then it is said to be a homogeneous function of degree alpha. So if we replace x by t times x and y by t times y, and if it is possible to factor t or the powers of t as shown in this equation, then the function f is called a homogeneous function of degree alpha. For example, if f of x comma y equals x plus y over x, then it is homogeneous function of 0 degree. Since if we replace x by t times x and y by t times y, then we get this expression, which simplifies to f of x comma y. T's cancelled. So f is a homogeneous function of 0 degree. Homogeneous equation. Consider an equation y prime equals f of xy. This is called homogeneous if the function f in the right hand side of equation 5.2.1 is homogeneous function of 0 degree. For example, y prime equals x plus y over x is a homogeneous equation, since f here is a homogeneous function of 0 degree. Method of solution. If f in the equation 5.2.1 is homogeneous function of 0 degree and u is an unknown function of x only, then the following substitution, y equals x times u, transforms the equation 5.2.1 into a separable variable equation. Because if we substitute y equals x times u in the equation 5.2.1, in the left hand side, we would replace y prime by the first derivative of x times u, and in the right hand side, we would replace y by x times u. In the left hand side, we should use the product rule of differentiation, which gives x times u prime plus u. And in the right hand side, the homogeneity of f gives x to the 0, since f is a homogeneous function of 0 degree. We obtain this equation, which can be easily written in this form, where variables are separated. In principle, we can solve this equation by the method of separating variables. Let's have a look at an example. We want to solve this equation y prime equals x plus y over x. In the interval 0 to plus infinity. In other words, for x, positive. Let's have a look at the solution. Since we observed that the right-hand side of the equation is a homogeneous function of 0 degree, so we can use the following substitution: y equals u times x in the equation, and this transforms the given ODE into the following. The left-hand side would be replaced by the derivative of u times x by the product rule, which is x times u prime plus u. And in the right-hand side, we would obtain x plus y, which is replaced by x times u over x, which simplifies to 1 plus u. Then, by cancelling the common terms u from both sides of this equation, the equation reduces to this simple equation. By separating variables, we obtain u prime equals 1 over x, which, when integrated with respect to x, gives this equation, namely u in the left-hand side and natural log of x only without absolute value because x is positive, plus c, where c is an arbitrary constant of integration. Therefore, the general solution of the given ODE is y equals x times u, where u is replaced by the expression we just obtained, natural log of x plus c. Observe that the given ODE in example 5.2.1 can also be written in this particular form. Which is a first-order linear ordinary differential equation. Hence, can be solved by employing the technique we discussed previously. Please try to solve this equation also by the method of linear first-order ordinary differential equation, and verify this method would also give the same solution as we obtained by method of substitutions. Alternatively, if m and n in the following equation are homogeneous functions of degree alpha, then the equation is homogeneous, because this equation can also be written y prime equals f of x comma y, where f of x comma y equals negative m over n. Now, if we replace x by tx and y by ty in the right hand side, we would obtain minus m of tx comma ty over n of tx comma ty. Since m is a homogeneous function of degree alpha, we get negative t to the alpha times m of x comma y in the numerator. Similarly, t to the alpha times n of x comma y in the denominator, which gives minus which gives minus m over n. Or simply f of x comma y with alpha to the 0. So f is a homogeneous function of degree 0. For example, consider the equation here where m is a homogeneous function of degree 2 and n is also a homogeneous function of degree 2. So this equation here is a homogeneous equation.